Hey, welcome back. I am just checking my live stream, see how we're doing. Looks like I have an excellent connection, and I think I am live. Let's see. Let's check. How's that sound? I think it'll be a little better. Give it a second, let it update. Much better. Cool. All right. So I've been playing around with like how AI models can help my workflow. So I like using YouTube. It's a nice place where I can kind of get ideas out into the ether and just kind of talk about engineering and these kind of things. So this one's kind of a meta video about like how AI can help me help other people learn about AI and engineering and also engineering. So earlier this week, I recorded this video, or wait, let's go here. Oh my God, here we go. Copy, and then we'll paste it. And let's mute myself. So in here, I started talking about like, what's the difference between Newton's laws and Lagrange equations? And it's an introduction to an advanced dynamics course. So I liked recording the video, and I like doing this kind of thing. But there's a whole transcript, like closed captioning is here, which is great that it's much more accessible. But I'm wondering, is there any way can I turn this into like a web page and start collecting these videos in a nice format where you can get a sense of like what's in the video before you jump right in, rather than just a little thumbnail and here just an introduction like Julia, introduction, blah, blah, blah. All right, so what I did was grab this YouTube transcript, and this code is awesome. I really like, it didn't work. I'm gonna close that out. Let's copy and paste YouTube API. It's a pip install YouTube transcript API, so you can actually grab transcripts from YouTube. And the nice thing here is when I do that, it tells me my video ID, which is the same ID as over here, just this part. Whether it's live or youtube.com doesn't really matter. And then I can go through the script and it tells me what the start was, how long it was. YouTube, grab one, just double checking. Let's go like, what was the last thing I said? So last thing I said was next time. So let's look at like the last 10 snippets that I had. So I said, this is a Lagrange equation, we'll get there, so we'll figure out. And so if all I did was grab this text and plug it into a website, then there'd be ums and likes and yeahs. So I don't want to do that. But I have all the script. I have the script information. It's all there. That's too much output. So let's just look at, let's grab 25. Well, 42 is really the answer to everything. Kinetic energy, that's the answer to all of life's problems. So now for reproducible kind of website building, I'm going to create this header where I'm giving some input to my AI model. So I want this AI model to act as a writer, And I give it an example of like, say, okay, we're going live and I'm live. Then that becomes, okay, we're live. So kind of summarizing, but also just cutting out language. At least this is what I want it to do. And the final result is that if I get some markdown files that are just the script, then I should be able to, should be able to get this. So I'll run that. I'm just making, so I'm using Python to grab the text, the actual captions from my video. And because I live streamed it, it actually took a couple hours for the captions to be generated. I tried to run it right after, but there were no captions. So YouTube has some kind of automatic processing. It just takes a little bit of time. And I'll make an output with that video ID. And now over here, let's zoom in, Control Shift. How do I zoom in? I just want to make this text a little bigger. That's a good question. I guess I could just change the font. Make the font bigger. That would work. Make it size 20. And cool. And let's just clear this. And what I'm showing up here is that I've got this Jupyter notebook running over here. Down here is my current output that it created, but we'll pull that up in a second because I'll regenerate it. So let's just close that out. So now I'll say, oh, llama, and I want to go back up to I'm going to run this DeepSeek R1 latest. I'll input this output. So I created this output and I gave it that this video ID. And I'm going to output that into my Lagrange.md file. So I'll run this. Takes a minute or two to kind of think about it. And I say thinking, I'm anthropomorphizing here, but really it's just processing. It's running, it's taking my text that I plugged in here, dumping it into this model, creating a vector from that. From there, it's running it through a whole bunch of like nodes in this pre-trained model, and then finally outputting like what it thinks. Again, not what it thinks. It's generating some output based on some stochastic, and I haven't really changed the any of the parameters here. So let's say if I show a llama, there was a way that I could show, I think, so I'm using that 7.6 billion parameters. I have 38, 35, 84. Context length is 131,000. I think I can say model file. There's a way that I can see what's going on here. A llama model file. Run. So you can create one, but I think there's also just like see what the model file is. But there's options to change the temperature. So I could, right now the default seed is 42. That's what I usually use for my seeds. And then I think there's also, yeah, here temperature default is 0.7. If I wanted to make it more repeatable, I could put that down to like 0.1 or even 0 if I want the exact same output every time. And nice part, I mean, I'm using YouTube to host these videos and interpret my voice, but when I'm processing this, it's just doing everything on my local computer. That's why it's taking a little while. I'm also running a streaming service while I'm generating this output. But it's very nice to be able to control where my data is going and who's benefiting from this training part. And I'm trying to find, I want to figure out also for my own memory, there we go, show dash model file. That was what I was missing, dash model file. There we go. I want to delete this one. So I want to show DeepSeek with the model file. And now I could jump in there and start changing some of these parameters if I wanted. And yeah, so it was built with that model show. It's really taking its time today. It really has a lot to chew through, I guess. And one of the things, when I first did this, I told it that I wanted to turn the video script into a document, and I told it to be a writer. I think I said technical writer writing for a website, but it tried to like grab little bits and pieces and create more of like a popular science article of like, oh, this is a comparison between these two things and blah blah blah, all this stuff, and that's not what I wanted it to do. So here I specifically say, like, you're not summarizing the transcript, you're rewriting as a new document. And it worked a little better, and let's see what the output is in a second. And I'll take a look at the notes as we're kind of waiting on this. So here, what I was doing in this last video that I recorded, I looked at Newton's laws versus Lagrange with a spring and a mass. So Newtonian process is look at the force, set that equal to ma, and now my equation of motion is here. Versus Lagrange, I look at what forces are storing energy, and in this case, the spring stores potential energy, and then compare that to kinetic energy. So with conservation of energy, I could say that it's all constant, but with Lagrange equations, we look at this action, take some partial derivatives, so there's more work involved, but we do end up in the same place. Then the next thing that I do is compare that to like a moving pendulum, like if this pendulum can slide back and forth, then I look at how is kinetic energy defined, how is potential energy defined, and the motion didn't actually affect that potential energy, so that was kind of nice here. But the motion would definitely affect this tension, like the motion is going to change what that tension is, so I would have to solve for tension in terms of the motion and plug that in. And then finally, kind of coming through here, final equation is the same theta double dot, same equation of motion that I would get for a regular pendulum, but it also has this extra y double dot. And if I was doing Newton method and y dot was constant, then it would be the same equation. All right, how are we doing on our work? Almost. It's really thinking about it. Ah, so long. All right, let's see if I still have. Wait, I want a CP01. So at least we can look at what we got last time. Oh, it's already overwriting it. Should have put it into a new file, huh? Yeah. Okay, still thinking about it. We'll give it a second. We'll go check out what else we can do with our script. So let's see, what other outputs do we have? So there's my total script. Is generated, let's check that one. So there's different outputs. So it was a generated script. What else can I get? Tells me the language, English from auto generate, snippets. I don't know what these snippets are. Like, how is that different from the actual and raw data? That one must be, oh, I see. So that is this output. So I guess I could write, instead of script, I could say dot raw data. Because then the raw data gives me more of like a JSON output. Taking a look at. I wonder if there's a way to just grab the text. I don't know. Oh, there we go. Snippets.txt. Oh, so I could grab this if I just wanted, if I wanted to get rid of the. So let's try this. I for I in range of, let's look at the first 10 snippets. Not bad. So I could, so if I wanted, I could just go through all the snippets and dump those into a file and load that into DeepSeek and then go from there. All right, this thing's really taking a while. I don't want to keep waiting. So let's take a look at BI Intro to Cooper. And I use the same kind of thing, but this one I told it to summarize the video, like give it a 3 to 4 minute. You know what? Let's Google Chrome, Intro to Cooper, and we'll look at the Markdown preview. So I created this Markdown file, and it took my intro to, working here at UConn. So already there's some things that YouTube's going to misspell some of the words. So here I'm at UCONN, not the Yukon Territory. And it talks about like what my workspace was and a living lab. I don't know that I love this, but integrates latest technology, bike commute, environmental count. Yeah, I'm riding my bike just for fun, not so much. I mean, I'm interested in environmental work, but join his YouTube channel. So this is a nice like workflow, and I think once this is done, it will help out. But I like this part that I can create kind of customized inputs and give it script, like fetch the scripts from YouTube and then dump that into a model. And I'm not dumping it onto a server to run, I'm just running it on local hardware. It's still using energy, so there's still the issue of like, where did that energy come from? How are we flipping all those zeros and ones? But it's all local, not depending on someone else to store this out in the ether somewhere. Okay, well this one is still running, and maybe next time we'll take a look at what the output was and see what else we can do and keep running from there. Okay, thanks for joining, and I'll see you next time.